inelastic collisions are collisions that do not conserve kinetic energy. They do, however, like all collisions, they do conserve momentum. So they don't conserve energy, like we said, and they're going to stick together. And that kinetic energy that's not being conserved is lost to heat and sound and things like that. When you're trying to tackle inelastic collision problems, you have 3 steps. They're much easier to solve than inelastic collisions, than elastic collisions. The first step is just to find the initial and final momentum, and then you're going to set the two equal, and you're going to solve for whatever you want. They're really pretty straightforward. So let's just take an example. Let's say I have an object with a mass of 2m, moving with a speed of v to the right. I have an object of mass, let's say m, just sitting there. Okay? So this is before the collision. And this initial velocity is 0. And I want to say, okay, what's the speed of the objects after the collision? Well, we draw our after picture, and afterwards they're both going to be sticking together, right? So we'll have, really you could draw either 2m and m and then connected like this, or you could just add up the masses and say now you have 3m. Either way, they're going to be moving to the right with an unknown speed, which we're going to call u, and that's what we want to solve for. Okay? So let's go through our steps. So our initial momentum here is this object has a momentum of 2m times v, and this has 0. So our initial momentum will be the sum, which is just 2mv. Our final momentum, now we have a mass of 3m moving with the speed of u. So our final momentum is 3mu. Now we set them equal. This was step 1. Step 2, we say, okay, 2mv equals 3mu. Cancel the m's, divide both sides by 3, and u is equal to 2/3 v. So the object hits, and it slows down a little bit. It slows down by 1/3. By a little more than that. But it slows down, yeah, by 1/3. So that's great, because what's also happening is its mass is going up by 1/3 m, and its speed is going down by 1/3 v. And this fits because this means momentum is conserved. Let's do one more example. Let's say this time the two objects are both moving towards each other, and then they'll collide inelastically. Let's say I have an object of mass m moving to the right with a speed of 2v, and an object of mass, let's say 6m, moving to the left with 1v. So which way should the objects move after the collision? If this is before, the objects are going to move in the direction of whichever one has more momentum. This has momentum of 6mv, and this has momentum of 2mv. So the objects will be moving to the left. Okay? After the collision, they're going to stick together. 6m and m. And again, it really doesn't matter what direction you choose your arrow to be. We know it's going to be to the left. I'm going to say it's to the right. And that is going to be traveling u to the right, and I want to solve for this u. And this is my u now is going to come out with a negative number, because my u is my velocity, and I'm assuming my velocity is positive. I know it's negative. So if I make it to the left, it will come out as a positive number. Just try to make sure you keep track of the signs and you don't lose track of which direction it's going in. So going like this, we have, if you choose it to the right, you just choose it to the right every single time. You know, oh, I got a negative. It's actually moving to the left. Or you can try to figure out which direction it's moving based on momentum, and then have that direction be positive, and then just remember that your answer is in the direction that you chose, not necessarily to the right. Okay? So negative just means that you chose the wrong direction. Our initial momentum then is going to be the sum of these, right? So if we choose right to be positive and left to be negative, 2mv minus 6mv, which is 4mv negative. Our final momentum, I'm going to pretend it's moving to the right. I'm going to say it's 6mu. So we set these two things equal, and we have negative 4mv equals 6mu. M's cancel. U is equal to negative 2/3 v. Well, it's the second time I chose a ratio with 2/3 v. So the negative sign means it's going to be moving to the left, right? If we had said originally it's moving to the left, right? Let's say instead this is going to the left. Well, if that's going to the left, that means this is negative, right? So then negative and negative, so they cancel, and then this is positive. And all that means, not that it's moving to the right in the positive direction, but that you chose the correct direction for it to be moving in, because now this is a speed, not a velocity. So our answer is u, the vector, is equal to 2/3 v to the right, left, sorry. Right? Or you could just say u is equal to negative 2/3 v, since v, the vector of velocity we said was to the right. That's why this v is negative, because of the positive direction. So that's how you do inelastic collisions. It's really, this is about as hard as it gets. Initial momentum, final momentum, set them equal and solve. You're not always going to be asked to find the final velocity, but if you ask for anything else, the mass, the initial velocity, it's just algebra. Only difference is algebra.